Hi everyone, so this is question 5, tutorial sheet 2. Then the question says use the basic trigonometric identities to find the remaining trigonometric functions. So on this question it's a little bit straightforward. For instance, the first question here, question A, is saying sine theta is equal to 4 over 5. So it's saying sine theta is equal to 4 over 5. And the terminal side of theta lies in the first quadrant. So the terminal side of theta lies in the first quadrant. So this statement is just telling us to say theta is positive. Yeah, theta is positive because we all know to say sine is positive in the first quadrant. So theta is positive. So now, for such questions, you have to draw this triangle. Then your theta will be there. And okay, let me draw it as if it's in the first quadrant so that you understand what I'm talking about. So a triangle in the first quadrant looks like this. Your theta will be there. Oh no, sorry. Yeah, supposed to be like this, the way I drew it. So your theta will be there. And then sine theta is opposite over hypotenuse. Let me show you this. Yes, so sine theta is opposite over hypotenuse like this. Opposite over hypotenuse. So if our x here is our theta, meaning the opposite will be this, the opposite part of the triangle to the angle is the opposite, and then the hypotenuse is the longest side, and the adjacent is the line attached to the angle. So same applies here. So sine theta, we are saying it's opposite over hypotenuse. So if it's opposite over hypotenuse, it means that our opposite is 4, and then our hypotenuse, our opposite is 4, and then our hypotenuse is 5. And then when you use Pythagoras here, you find that your adjacent is just going to be equal to the square root of 5 squared and then minus 4 squared. That is according to Pythagoras theorem. So this is the adjacent, which is equal to 25 minus 16, you get your 9, and then the square root of 9, you get 3. So this part is 3. So this part is 3. So now let us find the remaining trig ratios, trigonometric identities. So the remaining trigonometric identities will be cos. Let us try to find cos. Cos theta using this same triangle. So cos, we all know to say cos theta is nothing but adjacent over hypotenuse from Katoa, meaning it is just adjacent over the hypotenuse, and then tan theta we know to say is the opposite over adjacent. So let's proceed. So cos theta we know to say it is the adjacent, meaning it is 3 over hypotenuse, which is 5. And then our tan theta will therefore be, so our tan theta will therefore be the opposite over adjacent. So tan theta is opposite over the adjacent, which in this case will be the opposite, meaning 4 over the adjacent, which is 3. So it's going to be the opposite, which is 4, and then over the adjacent, which is 3. So these were the missing trig ratios which they wanted us to find. Let's proceed. Let's check what question B is like. So B is saying cos theta is equal to negative 5 over 13. So cos theta is equal to negative 5 over 13. And then they are telling us to say the terminal side of this theta lies in the second quadrant. So we all know to say cos is negative in the second quadrant. That's the reason why our angle here is even negative. So the triangle in the second quadrant is this one. And then you have your opposite. According to SOHCAHTOA, cos is adjacent over hypotenuse. So this is what I'm talking about. For cos is adjacent over hypotenuse. So meaning my adjacent here is 5, and then the hypotenuse is 13. When you use Pythagoras to find your solution there, you find your solution to be 12 this side. You find your opposite to be 12 there. So now the remaining trig identities will be cos, it's sine. It's going to be sine theta is equal to, so sine theta is going to be equal to, so we know to say sine theta is opposite over hypotenuse, meaning it will be 12 over 13. And then your tan theta is going to be the opposite over adjacent, meaning it is the opposite 12 over 5. So tan theta is going to be 12 over 5. As simple as that. But wait, let us now try to check if these are the solutions. They are saying our theta lies in the terminal. They are saying our theta, the terminal side of theta lies in the second quadrant. Is sine positive in the second quadrant? We are saying all soldiers take cover. This is all trig ratios are positive, and then sine is positive there, then tan is positive there, and then finally cos is positive there. So let us try to check. This is going to be sine theta is going to be 12 over 13, right? Yeah, but is sine theta, and then they are telling us to say the theta lies in the second quadrant here. If theta lies in the second quadrant, is sine positive or negative in the second quadrant? It is positive, so we leave it like that. Now, is cos, is tan positive or negative? In the second quadrant, it's negative, so we put a negative there. So it's as simple as that. We move on to the next one, which is tan theta C. So C is tan theta is equal to 12 over 5. So you draw the same triangle again. Tan theta is equal to 12 over 5. Then they are saying the terminal side of theta lies in the third quadrant. Anyway, let's check. So the terminal side of theta lies in the third quadrant. Let me just draw the triangle there. There's supposed to be a symbol for 90 degrees there. And then theta, they are saying to say the terminal side of theta lies in the third quadrant. So for tan, we know to say it's opposite over adjacent. So meaning our opposite here is 12, and then if this is our theta, and then here we're going to have 5, meaning the hypotenuse there will be 13. Let us now find the remaining trig ratios. So the first trig ratio that we're going to find is for sine. So I'm saying sine theta is equal to 12 over 5. So we look at this triangle here. Sine is opposite over hypotenuse. So the opposite to this angle is 12 over 13, which is the hypotenuse. 12 then over 13. 12 over 13. Now the angle here is saying, the instruction here is saying the terminal side of this theta lies in the third quadrant. Is sine positive or negative in the third quadrant? Oh, sorry. Yeah, in the third quadrant. Is sine positive or negative in the third quadrant? It's going to be negative. So we move on to finding the next trig ratio, which is cos. So cos theta is going to be, you write that, cos theta is going to be adjacent over hypotenuse, meaning it's going to be 5, which is our adjacent here, over hypotenuse, which is 13. So this is going to be the answer, but check it again. Is cos a positive or negative in the third quadrant? Of course it's negative. So it's supposed to have a negative there. Alright, let's move on to the last part. So the last part of this question is saying cosec. They're saying cosec excuse me. So they're saying cosec is cosec theta. This is D. They're saying cosec theta is equal to negative 5 over negative 5 over 4. So this is cosec theta. Okay. And then there's also another condition here to say sec, they are saying sec theta is less than 0. So sec theta is less than 0 and cosec theta is equal to negative 1 over 5 or negative 5 over 4. So here what you need to understand is that you need to test this like question 1 in this same tutorial sheet. You are going to test that like this for you to know where this truly lies. So sec theta is less than 0. First let me write the quadrants, the trig ratios in the quadrants. So sec theta is less than 0 where cos is less than 0. So cos is less than 0 in the second and in the third quadrant. Why do I say so? When I say cos is less than 0, I simply mean cos is negative. So cos is only negative in the second and in the third quadrant. Now, when I look at cosec, cosec is only, this cosec answer here is negative, meaning it's showing that this sign is negative. And then which quadrants do we have our sign to be negative? It is in the third and in the fourth quadrant. So meaning where there are 2 ticks here, that's where my answer is. So meaning this this expression here lies in the third quadrant. So cosec lies in the third quadrant. So, alright, I've just remembered something and very important. So somehow, okay, let me just finish this one here. So cosec is equal to negative 5 over 4. So cosec is negative 5 over 4. So if cosec is negative 5 over 4, we draw a triangle. So the triangle is going to be for sine we say, we know that cosec is just 1 over sine. So sine is opposite, so our opposite there is 5 over, so this one here So this one is 1 over sine. So 1 over sine is just the same as 1 over that. So cosec, in order for us to get sine from cosec, in order for us to get sine theta from cosec, we need to divide this answer here by 1. So I'm going to say 1 over 5 over 4. 1 over negative 5 over 4, which gives you negative 4 over 5. This is what we're going to get. So meaning our opposite is going to be 4, and then our hypotenuse is going to be 5, and of course our adjacent will now be 3, like that. So from there now we can now get our oh, sorry for that. Just from this now we can get the remaining trig ratios. So we can get cos from there. So cos theta is adjacent over hypotenuse, meaning it's going to be 3 over, my adjacent here is 3, and then hypotenuse is 5, so it's going to be 3 over 5. So 3 over 5 is going to be your cos theta, but since we said we are in the third quadrant, this expression lies in the third quadrant. It simply means that the cos of theta in the third quadrant, cos in the third is negative, so you put a negative there. Then we move on to finding tan. So tan theta is going to be SOHCAHTOA, so it's going to be opposite over adjacent. So my opposite there is going to be 4, and then my adjacent of course is 3. And then since we're in the third quadrant, tan is positive in the third quadrant, so you leave it like that. And then what I said I'm going to show you after finishing is this. From all the questions that we've been doing, we've only been finding sine, cos, and tan. So make sure that when you're practicing, also find cosec, cotan. You find cosec. Let's take for instance on this same question C. The cosec of this question will be just 1 over that. So cosec is going to be 1. Cosec is 1 over sine theta, so it's going to be 1. My sine theta is that, so it's going to be 1 over sine theta, which is 12, negative 12 over 13. So my answer there will give me negative 13 over 12. And then you also move on to finding sec. So sec theta will be, you look at your cos. Cos is negative 5 over 13. So meaning 1 over cos, which is negative 5 over 13. And then you divide that, you find your answer to be negative 13 over 5. Then you also find cot. Cotangent theta is equal to 1 over tan. So 1 over my tan is 12. So my tan is 12 over 5. So meaning my cotangent is just going to be 5 over 12. So on each and every question that we have solved, make sure that you also find these other trig ratios, which is cosec, sec, and cotangent. So thank you very much for watching this video. Make sure that you don't forget to subscribe to the channel so that you don't miss out the oncoming videos on this platform. If you have any questions and any contributions, you can send them to this WhatsApp line here. Thank you. See you in the next tutorial video.